Hi students, so in our today's lab we will do some programming on threads. In our last class also we have done a few programming on threadscation, and we have gained some knowledge on what actually thread is, how it is different from process, why we need them during the multitasking, and what are the life cycles, why it is called lightweight process because it shares these codes and data sections with the others, but it has its own program counter register certain stack space. And then also we have come to know that we can implement thread by implementing runnable interface, and also extending the thread class. Then we have come to know that the advantages of threads means it's quick to response, it helps in multitasking, there are communications among them, inter-thread communication, and so on, so many things. But in our today's lab we will implement some methods. Okay, basically three methods we will implement. One is the yield method, another is the sleep method, and another is the stop method. So we can go directly to the program. You can in the program you can see that we have a created class A, class B by extending a thread class. Okay, so here the thread, if we create the thread, means that means if we create the objects of this class A and class B, it is supposed to run for the 5 times, both of them. But for the thread A, we can see for the first iteration, during the first iteration, it is the int method is called. That means it will relinquish its control to some other method. Okay, the very next method is a B, so obviously the control will go to class B, and then this B will run for the 3 times, and then it will be stopped forcefully. And then we are having our C class. C, it is also extending the thread class, and it's also supposed to run for the 5 times. But if k equal to 1 means during the first iteration it is sent to the sleep state for 1000 milliseconds. Okay, then the thread A, thread B, and thread C, those objects are created. So they are created. The start method is called with the help of those objects. Okay, so this we can see the output. The thread is started, thread B started, and thread C is started. But though thread A started first, but it will not run because when I equal to 1, during the first iteration, it will relinquish its control to some other method. Okay, that is a B. So the execution will start from B. Okay, thread B will run for j equal to 1, j equal to 2. Then again control will be back to thread A. So it will also run for 2 times. Okay. In the meantime, the main thread also will finish its jobs. It will complete. It will be completed. And then when the thread C is called, means when the start method of the thread C is called, then it executes for the first time, and when means when k equal to 1, it runs, but it is then sent to the sleep state for 1000 milliseconds. Then again, see, previously B ran for the 2 times, but we forcefully stopped it during the third time. So remaining, it will run for the remaining 1 time, j equal to 3 from thread B. Then from thread A, thread B, then the thread A will run for 3 more times because previously it runs for 2 times, 1 and 2. So then it will run for the 3 times more. Then it will be, we will exit from A. Okay. Then again C will start to run, thread C, and it will run for the rest 4 times. So here is explanation. Above method uses the yield method in thread A at iteration I equal to 1. Therefore, the thread A, although started first, has relinquished control to thread B. The stop method in thread B has killed it after implementing the for loop only 3 times. Note that it has not reached end of run method. The thread C started sleeping after executing for loop only once. When it woke up after 1000 milliseconds, the other two threads have already completed their runs and therefore was running alone. Okay, the main thread died much earlier than the other 3 methods. Okay, this is the explanation. This is how we can use this yield, stop, and sleep method. Now come to the thread priority. In Java, each thread is assigned a priority which affects the order in which it is scheduled for running. Okay. The thread of the same priority are given equal treatment by the Java scheduler, and therefore they see the processor on a first come first served basis. Java permits us to set the priority of thread using set priority methods as follows: thread name dot set priority, and in the bracket that we have to put a number which is integer type, and it is an integer value to which thread's priority is set. For example, we may need to answer an input as quickly as possible, so we will set some higher priority to it. Whenever multiple threads are ready for executions, the Java system chooses the highest priority thread to and executes it. It's very normal that highest priority thread will get the chance at the beginning. Okay. For a thread of lower priority, then to gain control, one of the following things should happen. The highest priority thread stops running at the end of the run, then or it is made to sleep using sleep method, or it is told to wait using wait. If thread of a higher priority comes along, the current running thread will be preempted by the incoming thread, thus forcing the current thread to move to the runnable state. Okay, then come to the program. Here the same thing. The class A also extends class thread class B also extends the thread class, and they're supposed to run for the 4 times. Okay, C also, this class C also extends the thread class. It's also supposed to run for the 4 times. Then we have our objects thread A, thread B, and thread C, but we have set priority to them. Thread C is given priority, highest priority, the maximum priority, it can be 10 or 15. Thread B has a priority which is one more than the priority of the thread A, and the thread priority, thread A has a priority which is a minimum priority. That means it's obviously the one. Okay, so suppose if it is a 1, then thread B has the priority 2 and thread C has a maximum priority. So then we called the start method using this thread A, thread B, and thread C, but they A has started first, but it has minimum priority. So the execution will start from thread B. B will run for 2 times, then C will be started. C has the maximum priority, so it will complete its executions running itself for the 4 times. Okay, then the main thread also ending its executions, and then the second highest priority, B has the second highest priority, so B also needs to run for the 4 times. Previously it ran for 2 times 1 and 2, j equal to 1 and 2, so then now it j equal for j equal to 3 and j equal to 2. Now it will complete, B will complete its execution. Now A has the minimum priority, so A will execute at the end of the program. Okay, means it will execute last. So the explanation is the above program ends its output illustrates the effect of assigning higher priority to a thread. Note that although the thread A started first, the higher priority thread B has preempted it and started printing the output first. Okay, immediately the thread C has been assigned the highest priority, takes control over the other 2 threads. The thread C is the last to complete. So that was your slide. Today you have to do 2 programs, you have 2 assignments you have to do and submit it. Okay, so bye for now, we'll meet soon.